break it down.
27.
How did you break down 1,024?
I put it in front of the
Okay, and what did you do in the calculator?
Just I put divided by 2 10 times.
Okay, but be careful. When you divide by 2, you did it 10 times? When do you know how to stop? Or how do you know when to stop?
Yes.
So, let me show you guys what you're actually doing. What you're actually doing is like the box method. If you're dividing by 2, dividing by 2, dividing by 2, you're saying, okay, 2 goes in how many times? And you guys should have gotten, I think, 512 times. And then you divide by 2 again. Daniel's like, nope, it's 10. Let's see. Then we have 2,056, or no, sorry, 256. Oh. Divide by 2 again. Who knows what's next?
128.
128. Divide by 2 again. Because 2 goes into 12 6 times, and into 8 4 times. If you write it down, you can keep good track of it and never get lost. Uh-oh, I'm starting to run out of room. 2 goes into 16. 8 times. 2 goes into 8. 4 times. 2 goes into 4. 2 times. And 2 goes into 2. Woo! So now we count them. Now some of you could have lost count when you were in your calculators, but if you write it down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10, that's what I said. Woo!
Now, hold on. We didn't rewrite this yet, though. At least I didn't write it down yet. Did you guys put the 1,024 underneath?
Yes.
Because it's the base.
Oh,
What you put in your radical? We're looking for groups of
3.
Oh, 10.
10. You have to have it.
Oh. Where's the 3 go? The 3 is there.
Outside.
Now, some of you might have put parentheses, but that was one of the things that we hadn't seen a lot of, because we had seen just ones with like to the first power, so we saw a lot of 1 over 2, 1 over 3, 1 over 9 yesterday. What you might have seen in homework that was new is sometimes there were numbers on top, like this 3. So you might have had to go back in your notes and say, wait, who goes where? And if you came back to that color-coded page in your notes, who goes where? You see why the 10, which was underneath, needed to go in the radical, and the 3, in the example we just saw, needed to go inside. So there is a proper way of doing this. Whatever is under the line is the radical, underneath is what the index is, or what root, what the groups of are that we're looking for. So we're looking for groups of 10 in the example, right guys?
Yes.
Let's come back. Do we have, if we were to rewrite this, do we have something grouped in 10s that we could use to take out our radical? Yeah. But my question is, what's left? We have a group of 10. What's group?
3 left.
And also the 2, right?
Yes.
So we say, okay, hey, group of 10, we got one. Sweet, we got a group of 10 2s. But did the 3 go away?
No.
No. So what would be a part of the answer besides, yay, group of 10?
Multiply.
We also, well, careful, is it 2 times 3 or 2 to the third?
2 to the 5.
Yeah, because the 3 was an exponent. We have to leave them in the exponent spot. So the harder problems have a big number that you have to break down. You're looking to see, hey, is there a group of 10? And there was. Perfect. There was a group of 10 2s. So we were able to take away the radical with that group of 10, but the 2 remained and the third power remained. So what would be the final answer to this problem?
2.
Yeah, you could box it, like the quiz, which you guys are going to get back today from last Friday. I let you guys keep it like this, especially if you didn't have a calculator. But, I mean, that's not a really bad one, because it's just 2 times 2 times 2, right?
Wait, why is it 3 again?
Oh, because back here in the beginning, Jerry, you see how there was a 3 up top?
Yeah.
So, in the radical, there was a third power that was extra above and beyond the 2 to the 10. And so when we saw that there was a group of 10 2s, we were able to kind of cancel out this radical. We were able to say, hey, group of 10, sweet, get rid of that. But the 2 remains and the 3 remains.
Okay.
So 2 to the third power is the final answer. So 2 times 2 times 2, some of you guys know, is 8. So yeah, your final answer would be 8. Melanie, what's that?
Can you explain like
where you crossed out. Like, I don't know how you get to that.
I haven't been really showing the crossed out because some people cross out a little too much and then they get confused. But can I show you maybe the crossing out with some examples we did yesterday? Because we did these ones yesterday, right? But let me show you how it would work with like the crossing out notation. So I could have rewritten this. What we did yesterday was like, hey, we're looking for a group of 3. Sweet, there's a group of 3 -5s. Perfect. But I could have rewritten it as -5 to the power of 3. And so using what I just did, if you can rewrite it with exponents, you can actually say, I want a group of 3. There's a group of 3. They end up undoing each other. Because you're answering the question, is there a group of 3? There is a group of 3 of 1.
Okay, but I just didn't know like how. Okay, so like there were like 4 -5s and b to the power 4. So that like number, I just didn't know like how you.
Yeah, so b to the power 4. If you want, I can also show it with rational exponents. Because another way of looking at it without just canceling out is if I had rewritten this as -5 to the 3/3, which is totally legal. 3/3 ends up reducing to 1. So some people like doing that, so you can see it. And then if it was 4, like if there were 4 of them, then this would be 4/3, which would be 1 1/3. Does that make sense? So what would this one be? 2 to the power of... So I could rewrite this as 2 to the power of 6. Which you could just reduce them away, but you could also rewrite it as 6/6, which becomes 2 to the 5. Yeah, so that might be a little bit easier. And there are harder ones where you might have 4 or you might have 5 and it doesn't match up, but we haven't really seen those harder ones yet. Okay, so then coming over here, we can come back to our warm-up example. And so if it helps some of you as far as the canceling out, there is another way to go. Now, if this way makes sense, you can kind of just tune me out for a second. Don't start talking, but tune me out. But if you kind of liked how I was writing those fractions a second ago, and they were canceling out naturally, guys, what happens when we have a power to a power? Do you remember? Multiply. So couldn't we have made this the 10th root of 2 to the power of, we could have simplified this. 2 to the power of what? 10 times 3 would be 30. And so then we could go back to that fractional form of 30/10. And what does 30/10 reduce to be?
3/10.
Yeah. You end up at the same answer. So if you do have way too many, you can actually, I just saw a group of 10, so I took away the root with the 10th power. But you could also actually figure out how many 2's there are in total with the cubing, and then you could go ahead and rewrite the radical to rational exponent form and say, hey, I can do that. I can reduce. That ends up being 3/1. And 2 to the 3 is 8, just like over here. Just like over here. Okay, what does this page kind of show you? The problems get
Easy.
oh, maybe. That would be a good thing. I was thinking the problems get harder. That's kind of what I was thinking, because I gave you a 1024, which is huge, right? And I gave you a 10th root, which is huge. And there was this funny cubed in there. So what we need to do today, I think, is talk about some harder problems. So I want you guys to go ahead and go in your notes. I know you have a homework. That we need to grade and go over questions to. And we will do that more towards the end of class. Just for a few of you, though, you might be like, you know what, this isn't too bad. This isn't too hard. And so in a little bit, when we start going over homework, some of you are like, I have no questions. I'm going to pass out the worksheet that's going to be homework tonight. Right now, I still just have the bookwork that we need to still go over. I'll erase it once we start going over it. But I want us to go to our notes and see some harder examples all together, not just as an opener, to get a few more harder examples in our notes. We're still in 6.2. This is our final day in 6.2. So I want you guys to go ahead and write in your notes this quick remember, because if you notice, what we just saw was a 10 on the outside and a 3 on the inside. So this is kind of like, okay, what if it gets harder? It's a reminder of the radical form versus the rational exponent form. If you you guys don't mind, I'm going to do my color coding again, just as far as this little line represents the radical. The line in the rational exponent represents the radical in the radical form. N in the denominator represents the groups of, I'm going to write that up here. The groups of that we're looking for. The A stays big the whole time. He's the base. So he's the big base number in the exponential form, and he's the big base underneath that radical. And then the one that gets the most confusing is this little guy. Sometimes it's an understood one. But sometimes it's an actual number like you guys just saw with the 3. Sometimes M is an understood one. Sometimes it's an actual number like you guys just saw with the 3. Now, with this being written down, if you're a highlighting kind of person, this is a really, really, really good thing to highlight. It's something that we've seen a few different times, going from radical form to rational exponential form. Let me do one more example before we kind of just tackle a few together in our groups. But I'm going to make this one just a little bit weird. I'm going to make this one just a little bit weird. What if I was to do the cubed root? I'm going to put it in radical form so our brains don't have to do that whole switching right away. Of 64 to the 5th power. Okay? A cubed root of 64 to the 5th power. Someone, anyone, a volunteer, brave and courageous, have a first step for us to do. Yeah, Jerry, what do you think?
Put it as 64 5/3.
Okay, we could do that. We could think of it as 64 to the 5/3. How many of your brains agreed with him that that was the very first thing you thought of doing? Okay, so like 3 or 4 of you. 3 or 4 of you. Which means a lot of you were like, I wouldn't have thought of doing that. We can solve that way, and there is a way to do that. But since only 3 or 4 of you saw that, can we hold off on that one for just a second? Does anybody have another way of going? Yeah, I do. Just make it 4. Okay, pause. How'd you get to 4? Isaiah was thinking of taking the 64 off to the side and breaking it down, like we did with the 1024. Now, does anybody have an idea as to how we could break down the 64? Now, I know what you said, and it was awesome, but let me see what they did. Yeah. Go ahead.
Keep dividing it by 2.
Okay, so if we keep dividing it by 2, kind of like we did with all the other ones, right? So if we divide by 2, can I do that real fast? 32, divide by 2, 16, divide by 2, 8, divide by 2, 4, divide by 2. Okay, how many 2's does there end up being?
6.
6. Now, is it bad that there are 6 2's? No, but why is Jonathan like, oh, bummer?
That does 5.
He was thinking it was 5,
Yeah,
we've already done it.
Yeah.
And what are we actually looking for? Groups of 3. So could we rewrite this as 2 to the power of 6? Yes. But what if we were looking for groups of 3? Do you guys see that there are 3 groups of 2 2's? Or another way of looking at that is, did you guys hear Isaiah say 4 a second ago? 64 could also be 4 times 4 times 4. There's a group of 3. So there are a few different ways of doing it. One is that we could plug in 2 to the 6th power, and I'm actually going to do that over here for those of you that were seeing this. We could make 64 2 to the 6th power. And we'll talk about that in just 1 second. But the other way we could have done it is we could have seen that it's actually, there is a group of 3. It's just not 2. It's with 4s. Now hold on, careful. That just replaced the 64. What else do I need to fill in over here?
Put the 5 in.
Good, there's still a 5. I can't lose him. And what else did I forget? I got him. I got him. I have him. Didn't I forget the cube root? So if we break down the 64, there are 6 2s. That's one way of looking at it. Or there are 3 4s. And what do you guys notice that we can do if we have 3 4s in a cubed root? Okay, so the groups of 3, we could actually say the radical is asking for groups of 3 and there's a groups of 3. What would be left? 4 to the power of 5. Bless you. But for those of you that are like, I would have done 2 to the 6th power. That's what I would have done. Maybe you would have done that under the radical. Maybe you would have done that over here. How could we have put all these powers together? Guys, if it's just a 6, what's the understood denominator? Over 1. And what do we do with power to a power? We multiply. So you could have multiplied 6 over 1 times 5 over 3. You would have gotten 2 to the power of, what would your numerator be? 30. What would your denominator be? How many 2's are there? 2 to the power of?
10.
10. Wait a minute, is this the same thing? My people who learned how to do powers in their calculator, can you do 4 to the power of 5? What do you get? People who learned how to do exponents in their calculator. 1024. And what did we just see that 2 to the 10th power was? Either way gets you to your correct answer. So was this one right? Totally. Was this one right?
Yeah.
Totally. Because isn't 4 2 squared? And 2 squared times 5 would be 2 to the 10th. So both answers are right. Both answers are correct. And I would have been fine with either one because they both lead you to 1024. So here's what I want you to do. Some of you would have naturally gone this way, and I kind of forced you to go that way. Some of you wouldn't have even thought of that, and I kind of went this way but showed you the other way. I think right now we need to get you guys doing some problems on your own so that you can work with it on your own. But I'm going to walk around trying to answer some questions and just see how much of homework you attempted last night before we grade it. Okay? So let's go ahead. In your notes, stay right there. In your notes. You're allowed to work together with your groups if you want. But if you want to just kind of try it on your own and see what you can do, you're allowed to use a calculator. There's still some extra ones. Don't get the big ones because most of their batteries are dead. Get the normal calculators in the box up there if you want. But can I have you guys try to, just these 2 example problems, and I'm going to start walking around. Open up your homework in your spiral so I can just see what you tried. Instead of Friday. I haven't announced it yet, but yeah, you're right. You're totally right. So you guys are in your notes, your homework spiral, just sitting there for me to come look at. And if you have a question when I get to your desk, you can ask me then, okay? So ready, set, you're only allowed to be talking to people in your groups if you want to work with them. And if so, turn your desk so that you guys can work together. If you want to try it on your own, that's totally okay too. Okay, that's not math. Good try though. It is 1. Hang in there. Credit for trying. Pay close attention when we do example in class. Guys, turn to homework number 4 from last night. Page 303, numbers 13 through, 13 through 28, 31, and 36.
I was gonna say it's on my list.
Some of them get harder. Yeah, just because that's where you got stuck and see if that kind of helps you. Oh, got it. So you did that the first step. You used your knowledge. Yeah. Let me write. I'm going to do it. You can keep going. Yeah, and then you see the square root and the parallel. Yeah, can you rewrite it? Rewrite it with the 3 squared. So 9 becomes 3 squared.
Yeah.
And then go ahead and rewrite.
So ask for 2.
Oh, I would write it as 3 5 still counts. Doesn't that yeah. So, got it. Does that make sense? Yeah, good job.
Oh, that.
That was good. Okay, you're going to want to pay attention to us going over homework questions today in class, how to break down the big numbers, okay? Yeah. So I can give you credit for trying it, but you might need to fix it. Let's check it. Alright guys, you got a little bit of time to try number 7 and 8. Let's time out real fast. I started grading some homeworks and giving some advice. Can we try number 7 real quick and let me see how far you got? What did you guys do with the... Jerry, it's okay if you guys finish that question, just whisper. Okay. Because I told you guys to work on it together. That's okay. What did you guys do with the 125? Divide by? Kayla, you divided by 5? Did anybody else divide by 5 around the room? Okay. So if you divided by 5, did you guys figure out negative 125, what did it end up, or how many 5s did it end up having go into it? 3. Okay, so you did negative 5. That would have been a positive if you did negative 5. And then negative 5. Okay, you got 3 of them, right? Okay. So if you did 3 of them, there were a couple different ways of writing it. You could have done negative 5 times itself 3 times. And what does this little 3 in the radical, what's he asking again? Groups of, good, groups of 3, right? So some of you might have gone straight down to the answer of negative 5, and you would have been completely correct. But some of you might have rewritten that negative 5 to what power? So you could have rewritten it to the 3rd power, which we just saw a second ago, that cubed root and that group of 3 can reduce. That'd be another way of looking at it. But as I'm walking around the room, I see quite a few of you guys not just doing that radical form, but also doing that exponential form. Can someone tell me, how could you rewrite this with a fractional exponent? What would be on top? Careful, a 1/3?
3 over 1.
I'm still listening. I have a lot of advice, but I don't want the answer quite yet. What if I take away this crossing out for a second? What would be that numerator? Yeah. Remember, we just wrote it down in our notes, and we did it in colors and everything, right? What goes in the numerator of this fractional exponent? The exponent of the base, right? And what goes in the denominator? Which was the root, right? So let's go back. You have that in your notes, and your notes should be open right there because you're doing the example in your notes. So what goes in the numerator? 3. And what goes in the denominator? Oh, well, this time's kind of silly because they're the same thing, huh? So what can you reduce 3 over 3 to be?
1.
1. Now, were there a few different ways of getting to this final answer of -5? Yeah. Some of you saw it way back here, groups of 3. Some of you guys saw it here with the third root and the third power reducing. And then some of you could have gone all the way here and also gotten the same answer. Now, can we check out 64? Oh, wait a minute. Didn't we just do 64 a second ago? What did we learn about 64?
4.
Yeah, 64 can be either 2 to the power of 6 or 4 cubed. Does anybody know which one we're probably going to want to go for in this one?
4.
Yeah, because you see that 3 and you see that cubed root, right? So could we rewrite this as -4 to the power of 3? Now here's the struggle. I'm doing the negative because I see this negative number. Where does this guy go? Where's the 2/3 go? So far I've just rewritten the -64 to be -4. Okay, so I actually kind of have a few things going on. Now if you never go to radical form, could you still solve the problem? How do you keep going, guys? Power to a power? You multiply. How do I multiply 3 times 2/3? Does anybody like this better if I put it over 1?
Yeah.
I do too. So what happens if you multiply Eversy, okay? What's 3 over 1 times 2 over 3? Yeah, you could do 6 over 3 and then simplify, or you could reduce the 3's. Either way, do you end up with -4 squared? And what's -4 squared? 16. Okay, do you guys have any questions? Did someone get lost somewhere in the process? Is someone stuck behind? Is there anything that you guys want to ask? Clarify? Which one's easier to your brain, radical or exponential? How many of you guys would say radical? That's a little easier. Exponential? I think most of us have it tied.
Yeah.
Most of us have it tied. Okay, then let's go ahead and let's go back in your notes because I'm going to keep grading some homework. Some of you did a real good job of maybe rewriting it in homework or going from radical to exponential, but you didn't realize you were supposed to keep going. So I'm just giving you a quick heads up, like, ooh, some of these problems you're supposed to keep going. Because I don't want us to grade it and you be like, oh man, I'm missing a lot. You might have just not realized you were supposed to keep going in homework. Maybe you didn't grade the odds in the back to see what the answers were supposed to look like. So I'm coming around to see if you attempted it, and that's your credit for today if you tried homework, okay? But some of you might need to keep going to actually get those answers. Tomorrow we're going to go over homework questions because you might have missed a lot if we grade it right now, and I'll let you see the answers. But you might need to go home and work a little bit more on it tonight as far as to get to the final answers, okay? But before we do that, can I have you guys try 2 more? Let's see. Now, if you don't like this form, you can go to the radical. It's okay. I don't mind if you go to the radical form. Some of you might try it to keep it with these fractions, and some of you might go to radicals. I don't know. So let me keep on grading some homework, okay? It's just
Over 5. You two. Yeah.
Okay, so you do. It's
What do you mean? If you win the championship, during gloves and helmets. No. We're not hit, but not fight. Oh, it'll hurt. Yeah, but yeah. So you have a cage on.
Hey guys, was the 9 kind of weird with the 5? Yeah. Now, some of you, I saw a lot of you like the square root. And maybe even you put the 2. That's okay. It's understood, but that's all right. But a lot of you were like, ah. So what is 9? Did anybody break down 9? 3 times 3, or 3 squared. If you had rewritten that, now is it a little bit nicer?
Yeah.
Now, some of you might have jumped all the way down to the final answer, which is 3 to the power of 5, which you could put in your calculator and figure that out. Because the squared and the square root could cancel, and I get, see? And I get 3 to the power of 5 left over. The radical could go away with that squared. But if that didn't make sense, another way you could have done it is that you could have made this the square root of power to a power 3 to the 10th. 9 to the 5 is the same thing as 3 to the 10th. Now, if you had gone back to the exponential form, wouldn't it have been 10 over 2? And what does 10 over 2 become? Or 3 to the power of 5. Now, some of you with radical form, once again, once you saw that pair of 2 3s, you could go ahead and reduce a square root with the squared, and you would have had 3 to the 5th left over. But if you like keeping it in fraction form, you could have said, okay, so how many 3's are there? Well, 3 squared to the 5th is 10 3's, 3 to the power of 10. And then you could have gone ahead and done the square root of that and gotten 3 to the power of 5. Okay? Now, 256, do we have to break that down? Not really? What could you do? Yeah, this would have been to the 3rd power. What kind of radical would it have been? A 4th root. Good. But, guys, can we cancel out the 3 and the 4 right now? No. So we have to somehow break 256 down. Now, some of you guys figured out that this is the same thing as 4 times 64, which is pretty cool. And 64 is 4 times 16. So some of you were like, whoa, whoa, whoa. 4, there's way more 2's than 4. So some of you might have been looking for 4's instead of 2's. And if you did that, how many 4's do you end up with? So you could have rewritten this as 4 to the power of 4. What's the final answer?
4 to the power of 3.
4 to the power of 3. Because my 4th root and my 4th power, I could be left with 4 cubed. Now, once again, if some of you guys like those exponents, you could have done power to a power you multiply. And you would have also gotten 4 to the power of 3. Okay, kiddos, here's what I saw on your homework as I walked around. Here's what I saw on your homework when I walked around. I saw a lot of people, because the homework problems had big numbers and they had numerators and denominators that kind of either just figured out how to use their calculator really well, which the calculators aren't allowed on the weekly quizzes, which is why I let you stop here, or I let you stop here. And I would give you smaller numbers. Or some of you guys, I think, might have just kind of gotten some answers from the back of the book, or you didn't know what the answers were supposed to look like. So I gave some of you advice like, oh, I'm not sure, oh, I don't think you know what you were doing. Because you need to be able to show the grouping and to show the work as to why the answer is what it is. I'm not just looking for the final answer. I'm looking, do you know how the exponents and the radicals work? Now, the nice thing with the puzzle worksheet I'm giving you tonight, the only extra homework is that you're matching, so it's a little bit easier. You don't have to come up with the answers off the top of your head. Some of them are just rewriting, which a lot of you have been practicing, and so it's been really helpful. Because you've been going from radical to exponential and the other way. There's some easier problems in here. And it's matching. But there are some bigger numbers you need to break down, and no one needs quite yet. Do you remember what happened last time I gave you a worksheet? I walked around and I graded, and what did I have to tell a lot of you guys? Yeah, not just the letters that show your work. Not just the letters that show your work. So that's how I'm going to be grading tomorrow, not just the letters that show your work, but I am here today after school and tomorrow after school if you want to study for your quiz. Bye, guys. Remember, the quiz is on homework. You have to know how to do the problem. Not just have the answer.
Wait.
Average weight.
It's really fun.
Yeah.